Welcome back to Maths in an Empty Classroom with me, Mr. Southern. This is part 3 of the lesson on radians, and in this video I'm going to be going through another geometric example. Okay, so here we have, in the diagram above, OAB is a sector of a circle, radius 4 metres, and chord AB is 5 metres long. We're being asked to show that the angle AOB, which is this one up here, is 1.35 radians, and to find the area of the shaded segment. I should say that this example is taken from the Edexcel Year 1 Pure textbook. We have the angle here that we're trying to find, and we have 3 sides. So in part A, we're going to have to use the cosine rule. And some people will learn the rearranged version of the cosine rule. My preference, and what I encourage my students to do, is just to use the original form of the cosine rule and to substitute the numbers in and rearrange it with the numbers in it. So we've got a squared equals b squared plus c squared minus 2bc cos a, and I'm going to substitute in the values. Now, a is the side opposite the angle, so that's going to be 5 squared. B and C are both 4, so 4 squared plus 4 squared minus 2, 4 cos theta, because at this stage we don't know theta. Okay, so let's just tidy that up a bit. 5 squared is 25, 4 squared plus 4 squared, that's going to be 32. 2 times 4 is 32. So we have 32. Minus 32 cos theta. And what I see students doing at this stage is saying we can do 32 minus 32. We can't. This 32 is on its own. This 32 is being multiplied by cos theta. So what we need to do instead is to add the 32 cos theta over to the left-hand side of the equation, subtract the 25 to say that 32 cos theta equals 7. Which would mean that cos theta is equal to 7 over 32. To find the value of theta, I'm going to do the inverse of cos, so cos inverse of 7 over 32. Make sure that my calculator is in radians mode, and I'm expecting the answer to come out as 1.35. Which it does, 1.35026, we'll just do a few more decimal places there. And we have therefore shown that theta equals 1.35 radians to 3 significant figures. Incidentally, C is the symbol used for radians. Okay, part B is asking us to find the area of the shaded segment, which is this bit in yellow here. So to do that, we're going to need to work out the area of the sector, and then we're going to need to subtract the area of the triangle. So let's just jot that down here. So the area of the segment is going to equal the area of the sector minus the area of the triangle. Now the area of the sector, we're going to be using half r squared theta, and the area of the triangle, we're going to be using a half AB sine c. The angle we now know is 1.35. We know that the radius is 4, and that's all the information we need. So in here, half, the radius is 4, so 4 squared times by theta, which is 1.35, minus a half, A is 4, and B is 4, sine of the included angle, which is 1.35. So here we're going to get 10.8 minus 7.8057. So finding the difference there, we get 2.9942. So checking the accuracy required, no accuracy asked for, so we'll go 3 significant figures, 2.99 centimetres squared. to three significant figures. Okay, so we had the area of the sector minus the area of the triangle. Now, if you want to stay on, there is just a little extra here that's quite cool. In this specific scenario, where we have a sector of a circle and then a chord creating a triangle, we can actually generalise this form here, because A and B will both be r, they'll both be the radius of the circle. So we could actually have said a half r squared theta minus a half r squared, because A and B are both r, we're multiplying together, sine theta, which you can then factorise to being a half r squared theta minus sine theta. It's just a little bit extra, it's quite neat, it's not something you're going to use in many contexts apart from this one, but I just thought it was cool. I'll see you in the next video.